The derived set S dash of a bounded infinite set S, which is a subset of real number R, has the smallest and the greatest members. Proof. Let S be a bounded infinite set. Therefore, S dash is always bounded set. By Bolzan-Weierstrass theorem, every bounded infinite set has a limit point. So, S has a limit point. Thus, S dash not equal to phi. Case 1. If S dash is finite. Evidently, S dash has the greatest and the least members. Case 2. If S dash is infinite. By the order completeness property, every non-empty set of real numbers which is bounded above has the supremum in R, and every non-empty set of real numbers which is bounded below has the infimum in R. Thus, S dash has supremum let capital M and infimum let small m. We have to show that small m, capital M belongs to H dash. Since capital M is the supremum of H dash, there exists xi belongs to H dash such that capital M minus epsilon which is less than xi which is less than m implies that capital M minus epsilon which is less than xi which is less than capital M plus epsilon. Thus, capital M minus epsilon, capital M plus epsilon in open bracket is a neighborhood of xi. Since xi belongs to H dash, implies that in open bracket capital M minus epsilon, capital M plus epsilon contains infinitely many members of S. Implies that capital M belongs to H dash. Again, since small m is the infimum of H dash, there exists xi belongs to H dash such that small m less than xi which is less than small m plus epsilon. Implies that small m minus epsilon which is less than xi which is less than small m plus epsilon. Thus, in open bracket, small m minus epsilon, small m plus epsilon is a neighborhood of xi. Since xi belongs to H dash, implies that in open bracket, small m minus epsilon, small m plus epsilon contains infinitely many members of S. Implies that small m belongs to H dash. Thus, we get small m, capital M belongs to H dash. So, H dash has the smallest and the greatest members.